Three-phase motors are the workhorses of the industrial world. They power everything from pumps and fans to conveyors and machine tools. Unlike single-phase motors found in household appliances, three-phase motors use three alternating currents to create a rotating magnetic field. This field spins the motor's rotor, generating powerful and efficient rotational force. Like any machine, three-phase motors experience wear and tear over time. Insulation on the windings can break down, leading to shorts and reduced efficiency. Motor rewinding is the process of replacing the coils of wire that make up the motor's stator. These coils are critical for creating the magnetic field that drives the rotor. When the windings are damaged, the motor's performance suffers, leading to increased energy consumption, overheating, and eventual failure. In the following sections, we'll delve into the step-by-step process of rewinding a three-phase motor. Before diving into the rewinding process, it's crucial to determine if rewinding is truly necessary. Start by visually inspecting the motor for any signs of physical damage, such as burns, cracks, or loose connections. Next, test the motor's insulation resistance using a megometer. Low insulation resistance is a clear sign that rewinding is required. If the bearings are in good condition and the insulation resistance is within acceptable limits, rewinding may not be necessary. However, if the motor shows signs of significant wear, damage, or low insulation resistance, rewinding is the best course of action to restore it to optimal performance. Rewinding a three-phase motor requires a specific set of tools to ensure the job is done correctly and safely. Here's a rundown of the essential tools you'll need. Insulation tester, also known as a megometer. This tool is crucial for checking the insulation resistance of the motor's windings. Multimeter. A multimeter is essential for various electrical tests, such as measuring voltage, current, and resistance. Winding machine. A winding machine helps wind the new coils of wire onto the stator core. Bearing puller. If the motor's bearings need replacement, a bearing puller will be required to remove them from the motor shaft. Soldering. Iron and solder. A soldering iron is used to make secure electrical connections between the new windings and the motor's leads. Insulating materials. You'll need various insulating materials such as insulating varnish, tape, and sleeving. These materials help protect the windings from moisture, dust, and mechanical damage. Section 4. Rewinding Unveiled, a step-by-step guide. With the necessary tools and materials in hand, you can begin the rewinding process. Follow these steps carefully to ensure a successful rewind. First, disconnect power. Before starting any work on the motor, ensure it's completely disconnected from the power supply. This step is crucial to prevent electrical shock. Next, disassemble the motor. Carefully disassemble the motor, taking note of the location of all components, including the connections of the existing windings. Label the connections clearly to avoid confusion during reassembly. Then, remove old windings. Cut and remove the old windings from the stator core. Be careful not to damage the core itself. Clean the slots in the core thoroughly to remove any debris or insulation remnants. After that, calculate winding data. Determine the correct wire size, number of turns, and winding configuration based on the motor's specifications and the desired performance characteristics. Now wind new coils. Using the winding machine, wind the new coils of wire onto the stator core according to the calculated data. Ensure the coils are wound evenly and with the correct tension. Following that, insert coils into slots. Carefully insert the wound coils into the slots of the stator core. Use insulation paper or sleeving to insulate the coils from the core. Next, connect windings. Connect the ends of the new windings to the motor's leads, ensuring the connections are secure and well insulated. Use a soldering iron and solder to make strong and conductive joints. Then apply insulation. Apply several coats of insulating varnish to the windings, allowing each coat to dry thoroughly before applying the next. This step helps protect the windings from moisture, dust, and mechanical damage. Section 5. Reaping the rewards. Benefits of rewinding and safety first. Rewinding a three-phase motor offers several benefits over purchasing a new motor. It can save you money, as rewinding is typically more cost-effective than buying a new motor, especially for larger motors. Rewinding also reduces downtime, as it can often be completed faster than sourcing and installing a new motor. Furthermore, rewinding allows for customization, meaning you can adjust the motor's performance characteristics to meet specific application requirements. However, it's crucial to emphasize that motor rewinding involves working with high voltage and potentially dangerous electrical components. Always prioritize safety by wearing appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. By following the step-by-step guide outlined in this essay and adhering to safety precautions, you can successfully rewind a 3-phase motor, extending its lifespan, optimizing performance, and saving money in the process.